Ladies and gentlemen, good afternoon. Welcome to this first webinar of a two-part series on the TSI revision package. I am Cyril Martin, Communication Officer, and I'm honored to be once again your moderator. In this first session, we will focus on rolling stock and CCS. In the next session that will take place on the 6th of July between 12 and 1, mark your calendars, we will address the fixed installations and operation. As already announced, these two webinars will have a different structure than what we usually do. As we know that there is a high interest in this topic, we will dedicate a significant amount of time, around half an hour, to Q&As. And actually, depending on the number of questions we will receive, this webinar and the next one may even run a little bit longer than initially planned, up until 1:30, not more. So we have time to reply to the greatest number of questions possible. Last but not least, to ensure a focused and productive discussion, we kindly request that you limit your questions to the specific themes and topics covered in each of these webinars. As you know, the scope of TSI is vast, and it is not feasible to cover every aspect of the whole package within the allocated time. We thank you in advance for your understanding. So today, gathered around the digital table, I have the pleasure of welcoming Joseph Doppelbauer, the Executive Director of ERA, Antoine Defossé, Project Officer within the Rolling Stock and Fixed Installations Unit at ERA, Oscar Martos, Project Officer within the Rolling Stock and Fixed Installations Unit at ERA, and Juan Hernández, Project Officer within the ERTMS Unit at ERA. Thank you, dear colleagues, for being here today. Before diving into the heart of the matter, I would like to remind you that this event is being recorded and will be available on our website in the coming hours. And so will be the slides of the webinar's presentation. Due to a scheduling conflict, Joseph Doppelbauer cannot be with us as usual for his introduction. However, he will join us during the webinar and we will give him the floor as soon as possible. In the meantime, and without further ado, I now hand over to Antoine Defossé, Project Officer within the Rolling Stock and Fixed Installations Unit at ERA. Please, Antoine, the floor is yours.
Thank you, Cyril, and good afternoon, ladies and gentlemen. So I will give you some information about some key points of the TSI package 2023 relatively to rolling stock. Prior to that, I will give you some information about the status. So as you know, probably, or maybe you don't know, but then you are informed. The text of the TSI package has been adopted by the Railway Interoperability and Safety Committee on the 30th of March. Here you have a link to access the documents as adopted by the RISC. There are 4 documents, 4 Commission implementing documents. One will be amending the TSIs applicable to fixed installation on rolling stock. It will be an amendment, not a recast, so listing all the changes. It will list the changes brought to the Wagon TSI, infrastructure, PRM, energy, LOC&PAS, noise TSI, and also to the Register of Infrastructure. There will be a second Commission implementing regulation, which will be amending the OPE TSI. The third one will be repealing the CCS TSI. So in the case of CCS TSI, it will be a recast, so a complete new TSI, not just a list of changes. And the last one will be amending the decision on ERATV. So at the moment, these documents are being translated, and we can expect the publication during this summer. So today, we will concentrate on some aspects of the TSIs applicable to rolling stock and CCS. For my side, with the help of Oscar, we will present unique authorization for passenger coaches, derailment detection and prevention device for freight wagon, the noise assessment of composite brake blocks at IC level, and the new transition regime for TSIs applicable to rolling stock and CCS. And Juan will present the framework to manage specification changes and the enhancements of the CCS TSI. So let's start directly with the first topic, which is the unique authorization for passenger coaches. And you can go to the next slide. So just for your information, the things what we present is in the LOC&PAS TSI in paragraph 7115 and the subparagraph 71151 and 71152. So you don't have the text here in the slide, but when you go to the link provided at the beginning of this presentation, you can find the text of the LOC&PAS TSI. So what did we try to achieve with unique authorizations for coaches? Next slide, please. So it's to enable the authorization of a passenger coach in all member states with a single authorization. For those who know, the Wagon TSI is more or less the same principle as the paragraph 712 and the appendix C of the WAG TSI applicable to coaches. So what are the conditions to have a single authorization? The authorization is delivered by the agency. There is no involvement of the national safety authorities. There is no applicable national rule, consequently, and there is no designated body involved in the process. So that is the objective that we pursued. And we can already mention, ask a question on the next slide, what about no national rule? As you probably know, we have an ongoing project for the cleaning up of national rules. We started in 2016 with about 14,000 national rules, more than 14,000 national rules. Up to date, we have divided this number by 15 approximately, but still there are around 1,000 national rules that remain applicable. And some of these national rules are applicable to coaches, of course. So we had to follow several strategies in order to see how to deal with these national rules for the unique authorization for coaches. So there are principally two things we did. First possibility is to integrate these national rules in the TSI. When we integrate them in the TSI, we can integrate them as general requirements. That's what we did, for example, for the marking of coaches. We have in the paragraph 7115, which I mentioned, a requirement for the marking in compliance with EN 15877. And we have added this requirement because it is present in several member states as a national rule. So in that case, it is converted as a general requirement. So mandatory for all coaches if they want to get this unique authorization. We have integrated also in the TSI some national rule as specific cases. Here we have, again, two possibilities. We can have specific cases for which non-compliance will exclude the member state concerned from the area of use. Can give, for example, here the case of specific cases relative to fire safety. We have specific cases in Italy for fire extinguishing system. We have a specific case for the channel tunnel for the running capability. We have a specific case for Germany also about the assessment of emergency exits. So these specific cases are present in the paragraph 7115, and non-compliance with them will exclude the concerned member states from the area of use. So we'll reduce the area of use of the coach. In other cases, non-compliance with a specific case may lead to restrictions of use. This is the case, for example, for some specific case related to the platform train interface. We have a specific case in Spain, another one in Germany about the platform train interface. Non-compliance does not exclude the member states from the area of use, but may result in restriction of use, like in Spain, for example, for the Iberian gauge network, sorry. So this is the first possibility. We integrated in the TSI. So you will see in 7115 a lot of specific cases to be complied with, or we could reduce the scope. That's what we did, for example, for coaches equipped with a cabin. So the unique authorization will not apply to coaches equipped with a cabin because there are many national rules applicable to cabins, in addition to the fact that cabins generally also contain a lot of CCS equipment. So coaches equipped with cabin are excluded from the scope. We also excluded units with a speed of more than 250 kilometers per hour because there are also their national rules applicable. So that's the process we did. And we were still confronted with one specific issue with the national rules, which is the compatibility with train detection systems. In that case, it was not possible to include specific cases because the specific cases are not defined yet, and it was not possible either to exclude from the application the train detection systems from the scope. Otherwise, the area of use would have been nowhere. So in that case, we have a principle which is expressed in the TSI LOC&PAS, which is also expressed in the what we call the interface document, describing precisely the interfaces between the train and the train detection system, which is also expressed in the Article 13 of the CCS TSI. And it is a requirement for member states to notify their national rules in an harmonized way, according to the frequency management principle, before the end of 2024. So until this is done, we will still have the national rules applicable. We will still have a designated body for the assessment of those national rules, and we will still have the NSAs involved. But this is the last remaining point for which this is the case, and we hope that in 1.5 to 2 years, this will be solved by the notification of national rules as specific cases. So this was the first point about the unique authorization for coaches. So what we did with the remaining national rules. The second point is relative to the difference between point 71151, which I mentioned at the beginning, and 71152. So these concern two different types of operations for the coaches to be authorized. We have 71151 for coaches intended to be used in predefined formation. So when coaches are intended to be used in predefined formation, the interfaces between each coach do not need to be specified because this is internal to the project, let's say. Only the interfaces between the coaches and the locomotive and the coaches and the fixed installation need to be specified. So this is the first case, but for such coaches, there will be a clear conditions of use. They can be used only with coaches of the same type. They cannot be used in general operation. So we have the paragraph 71152, which provides additional requirements for the coaches when they are intended to be used in general operation, so to be used with other coaches from other manufacturers. In that case, it is necessary to specify the interfaces between all those coaches. So this is what is specified in 71152, and it's clear that this 71152 comes in addition to the previous requirements, and it's voluntary. They are not mandatory if the coaches are intended to be used in predefined formation. So these are the 2 points we wanted to mention about unique authorization for coaches. We hope that this will enable to simplify the authorization process for those coaches. And I said it's still a little bit work in progress for the train detection compatibility with train detection system, but at least we hope that it will solve a lot of issues with the involvement of several third-party assessment in the future. And now I will pass the floor to Oscar for the points relative to the freight.
Yep, thank you very much, Antoine. Hello, everybody. Good afternoon. So, regarding the derailment detection and prevention, which is one of the main changes brought to the TSI wagon and the TSI LOC&PAS, you find the requirements there. I will not enter in the detail of the requirement, but what I will try to outline is the different functions available in both TSIs. You have derailment prevention, which detects a precursor to a derailment, which can be anything. If the TSI does not really go into the detail there, could be you could fit different accelerometers, etc. But this is up to the up to the manufacturer, to the applicant, to decide how this is detected. And then you have a derailment detected, that would be the derailment detection. So these are the two possible functions. The important point is that they can be fitted in the freight wagons or in the locomotive, because during the discussion we have seen that some manufacturers were developing some items that were fitted in the draw hook of the locomotive, and they were able to detect a precursor to a derailment or a derailment in all the train composition. And then, but in any case, if you fit a derailment prevention or a derailment detection system or function, you will need to send to the driver's cab a signal, and the signal processing will be done in accordance with the point 42937 of the TSI LOC&PAS. This point is quite similar to what it is already done for the passenger alarm. So you have first an acoustical warning. If the driver does nothing, there is the initiation of a service brake application, which the driver can override at any moment. But the driver can, if during the alarm the driver ignores the alarm, then nothing happens, not even the braking start. So it is basically is a warning that will then start with a service brake application if there is no reaction on the side of the driver. As I said, very similar, and could even share the same interface as the passenger alarm. Next slide, please. And then the third possibility for the derailment is derailment detection and actuation. And in this case, there is a direct application of the brakes. So the system is completely fitted in the wagon. There is no driver intervention at all. And as soon as the derailment is detected, a device which is on the wagon will vent the air pipe. So there will be a complete stop to the whole train, no possibility of overriding. Of course, here the risk is that there is a false derailment that leads to a unsafe situation, such as stopping in a tunnel, or stopping or even creating a derailment because you stop. You make a very violent, let's say, a brake application in an area which there are a lot of curves, etc. So all these will be needs to be controlled to an acceptable level. And for this, we mandate a risk analysis for this type of technical solution to make sure that when it is activated, it is because there is a clear justification, because there is not a false detection. And then the only possibility to isolate this device is that the driver goes to the freight wagon and it actuates directly on the wagon once the train has come to a complete stop. These functions can be combined, as you can see below. The prevention and the detection by transmitting a signal to the driver, or prevention and detection by full brake application. Next slide, please, Anton. So now we go to the TSI noise, and in the TSI noise, the main change that has been brought is the definition of the interoperability constituent brake block or acoustic certification of brake blocks. So you find it in that part, in all this area of the TSI noise. And so the main points is that the interoperability constituent friction element for wheel tread brake already has the requirements, is already defined, but only the TSI wagon, and the TSI wagon has a complete definition of braking performance aspects. In the revised, could you please go? In the revised TSI noise, there are additional requirements for the acoustical certification. The same component needs to be then assessed at IC level for both TSIs. So the testing process is a bench test and is very similar. So the economical cost is kept controlled. There are existing exemptions for the TSI wagon, which are kept for the requirements of the TSI wagon only. And there are additional exemptions we are defined in the TSI noise for the requirements in the TSI noise only. When I talk exceptions, I mean historical break blocks that are currently used, for example, in the retrofitting of the freight wagons to make them silent. And they have the exemption is, of course, a temporary exemption, so they can be they will have the time to get this acoustic certification. In any case, and this is very important, the freight wagons must be assessed at subsystem level against the TSI noise. So the added value of this acoustic certification is twofold. First, as you know, in the pass by noise certification process, you can apply a simplified evaluation process, and having this IC certified will certainly help, because you have an element which is critical for the noise, and you have its acoustical characteristics well defined. And second, in future revisions of the TSIs, we may remove this need of systematically test all the freight wagons and just say that wagon which has these acoustically tested blocks is enough. No test is needed. It's TSI compliant. But for this, there is still some research that needs to be done. So we couldn't have it in this TSI. Next slide. And that's it. Thank you very much.
Thank you, Oscar. So next topic. So next topic is the new transition regime in the LOC&PAS, wagon and CCS TSI. So here it concerns those three TSI. So you can see the paragraphs impacted here. And I will get directly to the next slide to show how it applies to the rolling stock subsystem. So in the rolling stock subsystem, we have in the LOC&PAS and wagon TSI, we have the definitions that are pictured here on this drawing, let's say. We have defined the design phase for a project. The project includes the design phase and the production phase. The design phase starts with the contracting of the notified body. At that time, the TSIs applicable as the contracting of the NOBO are called the initial assessment framework. And the design phase ends with the EC type of design examination issued by the notified body. And the TSIs applicable at that time are called the certification framework. The end of the design phase marks also the beginning of what we call the production phase. So for those who are familiar with the current regime of phase A, phase B, you may think that we have just brought a change for the sake of changing. But it is not the case. There are really differences between design phase and production phase and phase A and phase B. And I would like to go to the next slide to show one difference already, which is quite important, is that neither the design phase nor the production phase are limited in time. At the moment, phase A is a maximum of 7 years in LOC&PAS and 4 years in wagon. Phase B is a maximum of 7 years in LOC&PAS and 10 years in wagon. In the new proposal, design phase and production phase are not limited in time, neither the first one nor the second. So this is a significant change. We hope it can bring predictability and visibility for the industry. That was really the aim of this change. Now there is a second change, and now it's not anymore maybe surprising, which is on the next slide, but maybe a little bit scary, I guess, for some those of you who are working in the railway industry, is that the notified body will issue the EC type or design examination certificate not according to the initial assessment framework, as was the case with phase A, because the beginning of phase A was setting the TSIs applicable until the certification, but the notified body will issue the EC type or design examination according to the certification framework, which is occurring at the end of the design phase. So why can it be scary? Because you may think that you, in case a TSI is enter into force 6 months before type certification, how is it possible to modify a rolling stock, for example? So, of course, this is fully understandable. So we have a very important also concept in the new TSI, which is on the next slide. So what we write in each TSI is that compliance with the previous TSI is deemed equivalent to compliance with this TSI, except for changes listed in Appendix star. So what is important really to have in mind is that now each time we publish a TSI, and this is the first time with this package 2023, we list the changes that this TSI brings compared to the previous one. And for all those changes that we list, we give a transition regime. There is a generic transition regime, which is of 7 years. So the TSI change applies only after 7 years. Or there are specific transition regimes, which are specific. There is no general rule. So this is very important to have in mind. So in all TSIs, there is an appendix. So it's Appendix A in the Wagon TSI, B in the CCS TSI, L in the LOC&PAS TSI, etc., where all the changes are listed and they are assigned a transition regime, meaning that for projects that are ongoing, so for projects that are already in the design phase, they will not apply immediately. And this is pictured on the next slide. So on the left is the beginning of a project. The design phase is starting with contracting with the notified bodies. There is an initial assessment framework which is defined, TSI ENE, for example. And when a TSI enters into force during the design phase, so this is pictured here with entry into force of TSI N+1, in the appendix, you will see all the changes. And the changes will not apply before 7 years for the generic transition regime, or depending on the change for the specific transition regime. So it gives visibility for the manufacturer, for example, to complete the design phase before the changes become applicable. And this is stated in the TSI. So in the TSI certification framework, it will be stated that the previous TSI was applied according to the transition regime. This is the case if one TSI enters into force. It is exactly the same if the second TSI enters into force during the design phase. The requirements, the change requirements from this second TSI will also apply after 7 years. So gradually they will become all applicable, but they are not applicable immediately, so that each time a TSI enters into force, it leaves the time necessary to finalize design phase. That's also a reason why the design phase is not limited in time, because anyway, if the design phase lasts 10 or more years, some TSI requirement will become applicable. This is really, we believe, a significant change, and that's why we make this presentation. In fact, what we did, we integrated somehow in the TSI for all the changes, the previous 7 years that was in the phase A, and that was freezing the design. Next slide, please. So after the design phase, so after the EC type or design examination, the production phase is not limited in time, meaning that there is no this clock that starts to turn with a maximum of 7 years, during which you can produce rolling stock in conformity to a type. Now, the production phase is not limited. So this is these are the significant changes we bring to the transition regime. Maybe you can go to the next slide. And a last point is that in the case of variant and version, the design phase is considered as starting at the same time as for the main type. So this is important, for example, if you have contracts for a platform of rolling stock, where you will develop some types immediately and some variants later on. The initial assessment framework is applicable to all the main type and the variants and the versions. So it means that the variants will benefit from the initial assessment framework of the main type. Well, this is very briefly what we can say about the new transition regime applicable to rolling stock. And now I will give the floor to Juan for the application to CCS.
Good afternoon, everybody. Thank you, Antoine. And then I will briefly explain how this generic transition regime, which is also applicable for CCS, is done in particular in this TSI. For the CCS TSI is the first time we introduce such provision, providing a specific definition of the transition regimes for the new functions or introduced. And then the main goal was to have a synchronized approach for the complete vehicle, now considering that it's composed of the rolling stock subsystem and the CCS onboard subsystems. And also to provide some, to remark some cascading principle that once you achieve one milestone, then you move to the next deadline in the next regime. So in the CCS TSI in Appendix B, we have classified the different transition regimes as applicable for the different elements of the CCS. So in principle, table B11 is for the requirements, the transition regimes for requirements for the onboard subsystems. Then on table B2, we have the transition regimes for the trackside requirements. We have a specific table, it's table B12, which is not directly for CCS, it's mostly for the rolling stock. But as all the train detection system or train detection compatibility requirements are hosted in the CCS TSI, then we keep them together with the specific cases. So this table, even if it's in the CCS TSI, is mostly for the rolling stock. And the last remark that is worth to make is that for the interoperability constituents, in general, the same requirements or the same transition regimes for the subsystem are applicable unless they have a specific definition in this table. So in this case, we have 4 requirements or 4 specific dates for CCS interoperability constituent. So this is about the generic thing. And then just to illustrate one example, I choose a simple one about the cool movement detection. This requirement was optional, is optional in the current TSI. Once the revised TSI entry into force, it will become mandatory. So the 4 cases we have covered in the TSIs is that at the design phase, a change on the CCS subsystem is made after the TSI entry into force. In this case, cool movement detection has to be considered if ETCS is equipped for the first time. If the design has already started, then there is a transition regime that these requirements shall not be considered until January 2028. And if the vehicles are already in production phase, then the requirement is not applicable until 1st of January 2030. If the vehicles are already in operation, then they are not impacted by this new requirement. And the cascading principle means that if you are already in the same phase and you complete it before 1st January 2028, then you move to the next column, to the production phase, and then vehicles following this design can be manufactured until January 2030. So this means that once you achieve the milestone in one column, you move to the next one. Then we move into what is specific changes that has been introduced in the CCS TSI, and we have choose 2 topics. The first one is the framework to manage specification cases changes. Sorry for that. The main scenario we have in mind when developing this change is that in the medium term, following the deployment plans in Europe, we will have a growing number of vehicles crossing different networks. So more and more vehicles will be crossing infrastructures in several countries and according to different engineering rules. So we need to achieve a full technical compatibility and interoperability among all the networks. For that, we have, together with the sector, identified some challenges. The first one is error corrections. Unless we all do the best to produce the specifications, after applications, we can find and get return of experience of some errors. So here the key message is that we need to analyze the potential impact of those errors on existing infrastructure and to avoid that these errors are reproduced in the future. Then, on the single set of specifications, the main idea is that we should not maintain in the legal framework specifications we have identified errors. And the last topic is the removal of partial fulfillment in order to have a better compliance between products and specifications. This is the topic we have chosen to highlight. There are other also relevant changes into the CCS TSI. They are summarized into the slides, but we will go on these details. So the first one we will go is into the error corrections. In this sense, this is a stepwise approach in order to try to get to the conclusion where these corrections is strictly needed to be applied. So this starts for a process that is being doing today. That is a joint discussion with the sector about which errors are relevant enough to impact interoperability. They are known as Article 10. In the revised TSI, this article has been renumbered as Article 9. And the basis for this is that questionnaires are sent to all the stakeholders to check the potential impact of this error into their products and projects. Once we have all the answers, the first step is for the IM, because the ETCS functionality is mostly trackside driven, that they need to check which is the potential impact on their projects. They have an option to implement mitigation measures if these things is considered by the IM as the best scenario. And then at the end of the day, the IM will publish in the Register of Infrastructure what are the applicable error chain requests that needs to be analyzed by the RU in order to run on their network. And this is exactly the next step, is that the RUs, with the support of the suppliers, needs to check about the identified errors by the IM, which one can really occur with their specific vehicles. And then if at the end of all this analysis, which is the key element, it's identified that the combination of the specific implementation in infrastructure with the products in the vehicles are leading to a potential error or interoperability issue, then this has to be fixed and changed with the support of the supplier providing an updated IC. In this case, when a change is made to the vehicle, then the impact on the authorization has to be analyzed according to the current basic design characteristics table, which is already present in the CCS TSI. Then on the single set of specifications, you know that currently in the Appendix A of CCS, we have 3 sets of specs. Then when we face the fact that we have to introduce a new one, we are thinking, okay, we make a 4th one. That's why there are 4 signals into the image. But then we get to the conclusion that it's not reasonable to keep or specifications in the legal framework with non-error. And also we need to achieve decoupling the error correction procedure from the introduction of new functionalities, because so far, every time we introduce new functionalities, we introduce on the same set of specs the necessary error corrections. Then the agreement is only one set of specifications will be kept on Appendix A, which includes all the functionalities and all the error corrections, so it will be fully updated. But in order not to lose the current flexibility that is given to the RUs to choose a simplified version of the onboard functionality, it will be produce what is called reduced envelope products that are based on subset 153 that I will detail later on in the presentation. But the former set of specs, in particular set 2 and 3, will be kept in the agency website, and then there is a possibility, according to the migration phases, to use it for a certain period of time in order to allow continuity and finalization of the ongoing projects. That is for the onboard, and then for the track side, it remains possible, as is currently today, to deploy any system version based on Chapter 6 of the SRS. So in this case, for the track side, it is still possible. But then the difference from the previous set of specs is that the Chapter 6 will contain all the error corrections that are already been fixed. So it's just one set of specifications that is fully updated and debugged with all the non-necessary corrections. And then the last part of this management framework for management specification cases is the removal of partial fulfillment. As I already introduced, the goal is to have a better alignment between product and specifications. Partial fulfillment was introduced as an idea to give some flexibility to the vehicles to include only the necessary functionalities for a specific piece of track, but having in mind the complete European network compatibility, all the mandatory requirements has to be implemented in all products. It's true that in some cases, this partial fulfillment is also used to overcome some errors or some gaps into the specifications. But then for that, we have discussed with the sector how to deal with them. In case new errors are detected while developing a product, that is mostly to happen when you are developing a newly introduced functionality, then suppliers can record a change request into the ERA database, and then until the agreed solution, the harmonized agreed solution, is reached or is raised in the agency working groups, then the supplier can develop and install their proprietary solutions, because we are aware that projects need to progress and they cannot be on hold for longer time in order to get to this solution. In some cases, we have jointly identified with the sector that it could be somehow of over specification because the requirements in the TSI are not realistic or are not necessary to achieve interoperability. In those cases, the right way forward is to amend the specification through a change request and to align it to the real requirements. And after discussion with the sector, we have finally introduced in the CCS TSI Appendix G, we give 3 exceptional cases where partial fulfillment of the TSI requirement are still considered, which is to keep DMI seal 0 for the case of upgrading B2 fleet. In the case that the development of system version product for product implementing system version 2.1 and 2.2 on the onboards, and in some specific cases to produce interoperability constituents specifically designed for catenary independent engines. Appendix G also provides the events that trigger the necessary to update and to get to a full compliant product. So this is what is on the main legal text of the CCS TSI. And then we get more into the technical details on the enhancements and which is the relation of this enhancement with the ETCS system versions. We have summarized here the main new features that has been introduced at technical level with ATO up to Graded Automation 2. Then the level 2, which is merged with the former level 3, providing for the first time a full specifications for operating with train integrity. On ETCS, we have provide the FRMCS and the FRMCS and DAC readiness. This means that it's already included in the ETCS and ATO in some cases products specifications. The necessary functions to be interfaced in the near future when FRMCS and DAC is available. Also, we have introduced modularity based on the Ethernet connection, both for the subsystem as the Ethernet bus and also for the interoperability constituent. So this will enable for new equipments to be ready for easier and quick interfacing with the new elements. And then on the train detection compatibility, we have, as already announced, introduced by Antoine, we have fully defined the target system. So we are closing all the related open points that were still missing on that part. And then I will further talk about the subset 153 in a couple of slides. The first question is, why do we need now a system version 3.0? That, as you know, when changing the first digit, it means an incompatible version. There are 2 key drivers for this. The first one is the obsolescence of GSMR. These are the telecom products based on all 2G specifications, and then they will reach the end of life in the near future. For that, ETCS needs to be prepared for the future introduction of FRMCS. Also, there are new functionalities, enhancements that has been requested by the sector, like the supervised maneuvers, which requires, in order to have full advantage of that the vehicles are fully equipped. So why to introduce it now if FRMCS and DAC, that is behind supervised maneuvers, are not yet fully ready? This will bring the opportunity for new investment on ETCS already to benefit for this functionality. So when FRMCS and DAC will be available, there will be no need to modify or to overcome new investments. And also in the particular case of FRMCS is already a step forwards the decoupling of the telecom transport layer for the signaling ones. So how this is organized, how all these new enhancements are organized in relation with the ETCS system version. Until now, we have system version 1.0, which is baseline 2. 2.0 was the first baseline 3 maintenance release 1, and system version 2.1, which on top of that introduced GPRS and online key management. In this revised TSI, we have introduced ATO as part of system version 2.2, which means that these trucks equipping ATO are still able to be operated by vehicles of the current system version, and then system version 3.0, which will be the ones that include the FRMCS and the supervised maneuvers. These new functionalities are not incompatible by definition, but they are incompatible because the old technology is removed. In this case, because GSMR is no longer supported or because something signals are removed. In order to allow an intermediate migration step for the IMs that wants to benefit in advance of this new functionality, but the RU fleets are not fully equipped yet, we have defined a system version 2.3, which allow to deploy the new functionalities while maintaining the compatibility. So this is what I say is just explained in the slide. And then I'm getting to the end. How the flexibility of the single set of specs is kept to produce onboard products that are compliant with the former set of specs. What we have currently specified in the ETCS baseline 4 is the full envelope of ETCS system versions to be supported by the onboard product. This means that this onboard product will be able to run in a truck site which is equipped from system version 1.0 up to 3.0 all inclusive. So this will be a complete and fully compatible vehicle that is able to run all over Europe. And then in these specifications, we have included all the error corrections. But then in these specifications, there is one part of the functionality that is defined only for the new functions. If we extract this functionality, we will have a reduced set of functionality, what is called a reduced envelope, that will result in a vehicle that it's capable to run up to 2.2. If we do the same exercise with the 2.2 functionality, which is ATO, then we will get with even a smaller size of the envelope of the functionality. Then it's important to highlight that the first reduced envelope up to 2.2, it will be equivalent to the current set 3 plus the ATO and the maintenance package. And here the key element is that this reduced envelope, according to subset 153, will have the same functionality plus the error correction. So it will be a fully debugged product and will not contain known errors. And the same that for the 2.1 reduced envelope will be equivalent to set 3 plus the maintenance. Now, regarding when this subset 153 will be available, today in the documents to be published in July, only the right part will be specified, and then in the subset 153 will be finished in the technical working group during 2023. In the meantime, as mitigation measure, in Appendix G, it has been listed the change requests that are related to the new functions. So it's possible for a supplier to construct the reduced envelope product based on the clauses that are impacted by those change requests. In order to be complete on this slide, the current set 2 specifications, which define up to system version 2.0, will be phased out. So this means that until 2030, it will be still possible to place into the market vehicle equipped with this, but not longer after that. And that's why this is not in the scope of Statute 153 to define this reduced envelope, but it will, because it's been phased out. And that are the key points that we want to highlight on the CCS TSI. And I give back the floor to Cyril for continuing the webinar. Thank you very much.
Thank you very much, Juan, Antoine, and Oscar. Before we move on to the extended Q&A session, so as we said previously, we will take your questions up until 1:30. We would like to express first our sincere gratitude for your overwhelming participation today. We can tell you that we have set today a new record in the short histories of ERA's webinars, and we are really happy to have such a large and engaged audience. And I would also like now to welcome Joseph Topol-Bauer, the Executive Director of the agency, joined us. And I'm happy to give you the floor, Joseph. Please, Joseph, the floor is yours.
Many thanks, Cyril, and good afternoon. Sorry for the slight delay of my participation to this webinar. I am talking to you from Madrid. Today there is another event, and unfortunately the schedule of that event was not kept. Now, this webinar really is covering an important topic, and this is also shown by the massive interest in the webinar. We are speaking of a major milestone on the way to the single European railway area. The TSI package 2022-2023 provides many interesting aspects, as you have just heard from Antoine, Oscar, and Juan. I just would like to mention a few. The new transition regime, the legal basis that we have created for combined transport, unique authorization for passenger coaches, and as explained by Juan in detail, the ERTMS game changers, ATO, FRMCS, and modularity, and a new approach to the ERTMS system versions. I would like to put this TSI package into the context of the European Union transport policy. You know that the name of the game is decarbonization of the transport system. And decarbonization of the transport system also means a modal shift to rail. But in order to have this modal shift, and we cannot force the users to use rail, the railway system needs to be attractive. To be attractive, the railway system needs to reduce cost. And costs can be reduced by standardization, meaning by adherence to the TSI and by more competition. Then, of course, we need to have more investment into infrastructure to have a high quality and capacity of the infrastructure. But we are still faced with many cross-border issues. The highest potential for modal shift in rail is in cross-border transport. And there, the TSI package comes into the play. And there we see most drastically the impact. In relation to ERTMS, this means we need the possibility to run with a single onboard unit on our vehicles. We have an ETCS where we can have full technical interoperability. If we have a reduced cost, the investment in infrastructure, and removal of technical and operational barriers, we can have an improved modal share for rail, and we can have a decarbonized transport system. Many thanks again to the colleagues who have explained in detail the contents of the package. There will be a second webinar on the remaining aspects of the TSI, and then I'll give back to Cyril for the question and answer session. Thank you very much.
Thank you very much, Joseph. Let's indeed now move on to the Q&As part of this webinar. So I have a first question to you, Antoine. Lots of topics are new with the TSI revision package and will definitely impact the way of working of the sector, applicants, manufacturers, and SAs. Do you envisage some dissemination campaign within the member states, Antoine?
Open your camera. Open your camera. Thank you, Cyril.
Your camera.
Thank you, Cyril. Yes, indeed, we think that it can be interesting to organize dissemination on topics like transition, because from the return of experience we have with phase A, phase B principle, we know that it takes time. So before everyone really understands the transition regime. So we think that with this new one, which brings significant differences, it will be necessary to do some dissemination right from the beginning in order to ensure that it is well understood. We believe that there are real advantages with this new regime, but it needs to be well understood and well applied. So I think we can take this opportunity today to call for, in particular, representative of NSAs or representative of ministries, for example, if they want to organize something for the sector or even sector organizations, if they want to organize something for their members, we are fully open to participate and to present in more detail, because here it's a very short presentation. We will answer also the question, but we think it's important to have the possibility to present in more detail, and we welcome. We will not organize something, or maybe we can organize something in our office in Valenciennes, but we can also travel and have local workshops, regional workshops that I think may be necessary.
Thank you very much, Antoine. The next question is for Oscar. Oscar, it's related to the derailment device. Oscar, based on which norms will the interfaces be specified? How will interoperability be guaranteed?
So, in the TSI, we set out functional requirements. We don't always need to refer to a norm. Only when there is a need to standardize because of technical compatibility or any other reasons, we then standardize. So there is no, we don't refer to a particular norm. Perhaps we could identify some in the application guide. But we give a complete liberty to the applicants to define the norm that it suits best. Also, of course, based on the vehicle it is going to be fitted in. So if it is for example, a UIC typical wagon system, which only mechanical and pneumatic interfaces, you will typically need to have something else fitted. But if you have a pre-existing Scharfenberg type with electrical coupler system, then you can use this one to already have the signal transmission.
Thank you very much, Oscar. The next question is for Juan. So regarding the transition regime for onboard CCS and focusing the question on the example you have shared, if a CA verification set of certificates is obtained for the subsystem, in the case of design phase has already started when the new TSI becomes into force, the verification process has not really finished for the subsystem, the vehicle, because a modification to encompass the CMD is needed before 2030, and hence a new certification process, isn't it? Thank you. Juan.
Okay, thank you for the question. I think it's good that we share this cascading principle. If the design phase has started and then the certificate is issued, we are entering in the production phase. Then here is true that we have two cases. If the production is finished and the vehicle is placed into the market before or is in operation before 2030, then this vehicle is moved to the final column, so the vehicle is in operation, and then this change is not applying to it anymore. In case that we have achieved the milestone of completing the design and have the certificate, and then these vehicles are not produced before January 2030, is right that these vehicles cannot be produced anymore, and then they need to be re-equipped. So this will require a new certificate. But then this is the cascading principle that when you achieve one milestone, you move to the next column. And then if for a specific big vehicle, it reaches to the end to be in operation, then it will be no longer impacted.
Thank you very much, Juan. The next question is very short and it's for you, Antoine. Does this new transition regime also apply to NNTR DBO certificates?
To our knowledge, no. It's the first time, I think, with the TSIs that we categorize the changes because it's necessary to categorize the change in order to assess to them transition regime. And I don't think this is done in any national technical rule so far.
Okay, thank you very much. Thank you very much, Antoine. The next question is for Juan. For projects which are already in state of advanced development in conformity with the previous TSI CCS, would it be possible not to apply this new TSI CCS 2023? Which process will be applied then? Please, Juan.
Yes, in this case, if the project is in advanced stage, as Antoine already mentioned, this is not longer relevant per se. You need to analyze which is the precise phase where this project is. First, you need to check which requirements from the new TSI are not being applied by this project, and then to check the specific transition phase or deadline that needs to be applied. So it's possible that some of the functionality and except error corrections for all changes, we are giving between 2 and 7 years in general for a full transition to the new TSI requirement. And if in any case, the non-application article from the directive remains available in all cases. So the transition regimes for the changes for the non-implemented functionalities should be analyzed. And as a backup, you always have the non-application request.
Thank you, Juan. Next question for you, Antoine. Question for future TSIs. Is it planned to standardize national rules on EMC, handling of equipment subjected to monitoring, etc., or to specify them completely in the TSIs, as future freight wagons with DAC or onboard control systems will run Europe-wide? Is it important to specify such topics? Please, Antoine.
Thank you. So the idea really is to harmonize the way these national rules are expressed. And the way these national rules are expressed should be according to the frequency management principle. So each, let's say, each member state shall notify specific cases according to a template which has been defined by our colleagues of the Train Detection Compatibility Working Group. So it's Annex B of the interface document. So this template should be used to notify all of the national rules that will be then specific cases in an harmonized way. And so it will be possible then to define for the coach the compatibility with all these specific cases, because they will be defined in an harmonized way. So this is the idea from now to the end of 2024, when member states will notify their national rules and specific cases.
Thank you very much, Antoine. Next question for Juan. We implemented TCS OBU in existing vehicles authorized in accordance with Directive 2008/57 EC or in operation before the 19th of July 2010. Regarding TSI 2023 transition regime, design phase started before TSI enters into force applies now. In case of extension of area of use for these vehicles in 2024, does this transition regime also apply, or does apply transition regime for vehicle in use? Juan.
In this case, we need to precise that the concept of extension of area of use by itself implies that there is no change to the vehicle. In that sense, if there is no technical change to the vehicle, so the vehicle is just moved to a new area of use, then it should be considered as a vehicle in operation. It is important to highlight that there is a section 7424 in the current TSI, and it's revised in the revised TSI, that explains what are the requirements for the cases of extending the area use of the vehicle. And in a summary, if the vehicle, the main thing to consider is if the vehicle is still compatible with the new area of use. For example, an easy case, you have a baseline 2 vehicle operating in a network, and you want to extend the area of use to a network which is operating a higher system version, for example, system version 2.0. In this case, the extension of area of use will require a technical change, and then this technical change will need to be done according to a new design. So, summarizing the answer, if there is no change, it will be considered like a vehicle in operation, but if a change is needed, it will be considered as a change when the TSI enters into force, because what it defines the status is each time design change is done into the vehicle. Of course, the requirements will only apply to the scope of the things that are changing to the vehicle. So these are two options, depending if there is a modification or not needed into the vehicle to operate in the new area of use.
Thank you very much, Juan. I have now a question for you, Antoine. Is it correct that once a type certificate is issued, vehicles can continue to be authorized against this type certificate for a limitless time period without re-verifying against the subsequent TSI updates, except for requirements with a specific transition regime? For example, no 7-year limit and also assuming no safety issues. Antoine, please.
Thank you, Cyril. Yes, to make it short, yes. The vehicle can continue to be authorized in conformity to a type after the 7 years, because there is no limited there is no limit in the validity of the type. It is also correct that only a requirement with a specific transition regime could make a type invalid. But otherwise, there is no limit in the validity of the type. Maybe I will give a few reasons why we do that now. Historically, you know that the TSI started to develop from the high-speed network, and then they were extended to the conventional rail network, and then they were extended to the complete European network. And then they were adapted to the fourth railway package. And this is the past, and now we think that the TSI are quite mature, and this is the reason why we think that now we can have longer type validity in order to enable longer production period in conformity to a type. That's really one of the objectives of this revision.
Thank you very much, Antoine. Juan, next question for you. Can an IM require CRs in the RINF, even though they are not relevant for the current infrastructure, but might become applicable for future updates of the infrastructure, just to be on the safe side? Juan.
Thanks. In this case, the question is regarding the error correction procedures. At what are the change requests that can be requested by an IM to the operating vehicles in that piece of infrastructure. It's important to highlight that this is a joint exercise. In principle, IMs should restrict to the current implemented functionality and only request the new change requests when the new functions will be deployed, because otherwise they will be forcing their use to implement changes that are not strictly necessary. So the whole exercise, or the whole aim of the exercise of the error correction procedure, is to identify the strictly necessary change requests to be implemented to keep technical compatibility and safety on the current operation. But this needs to be based on the current functionality, and this is the spirit where this requirement has been introduced in the CCS TSI.
Thank you very much, Juan. I actually have another question for you now, and actually lots of questions for CCS TSI. If a project needs to go into operations with CCS TSI compliant systems in 2027, do you consider it feasible and recommendable to go for the system version 3.0, Juan?
Yes, I think it's recommendable to go for this system version 3.0 because it will give you it will be prepared for the future and necessary change to accommodate to FRMCS. So if you do any investment now, it's reasonable to try to foresee to be already compliant with system version 3.0 because it will avoid to do additional investment in the future when FRMCS will be deployed. The other option is to deploy some of the products, but you need to foresee that in the medium term that this new functionality will be done. Of course, this will depend also, and this has to be checked with the specific area of use and the specific deployment plan by IAMs where these vehicles will be operated. But if it is foreseen that between 2027 and I think the dates for the deployment of FRMCS are around 2035, to avoid future updates, it's recommended already to invest and to optimize this investment. Of course, this needs to be checked with the feasibility of having already products that are being produced. And of course, there are some risk for being the first implementers of a new system version. But overall, if this 3.0 functionality will be implemented, and I think all IAM will need to switch to 3.0 to accommodate FRMCS, or more precisely to remove or switch off GSMR, then it will be an optimal investment strategy to go already for 3.0.
Thank you, Juan. Another question for you, Juan. When will the baseline 4 subsets, including the subset 153, be available on the ERA website?
In this case, the answer is in 2 steps. The baseline 4 subsets will be available as soon as they are adopted and published by the European Commission in the official journal. And this is foreseen over the summer. And for the specific case of subset 153, which is in the current voted test is reserved, it's planned to have an amendment of the CCS TSI in more or less 1 year time. So it's about summer 2024, together also with the subset 151 that is about ATO testing, and also the subset 76, which are the test cases for the ETCS on board. But the subset 153, it will be hopefully finalized in the working party in advance, and as agency we will analyze which is the optimal way of making it public, so they can be considered even in advance of their formal publication in the CCS TSI. But then, summarizing the answer, the documents will be in the agency webpage as soon as they are adopted and published by the European Commission in the official journal. And subset 153, it will take 1 year more because it requires an amendment of the CCS TSI, since in the Appendix A, the current status is reserved.
Thank you. Thank you, Juan. Back to you, Antoine, now. For a vehicle already in design phase, designed according to the current TSIs, provided no specific transition regime applies, does it mean that it can be certified according to the new TSI in 2024? So before the 7 years of the generic regime pass, even if not compliant with the technical requirements, is there then a time limit for placing on the market the vehicles in conformity to type if no further TSI is published? Antoine.
Yes, it is in the LOC&PAS and in the Wagon TSI. In both of them, we give the possibility for projects that are currently in design phase to either continue with the previous TSI. So by previous TSI, I mean the TSI LOC&PAS and Wagon, including all amendments until 2020. So they can continue to apply these ones, or they can switch to the new TSI. And by applying the new TSI, as they are considered in design phase, they will benefit from the 7-year transition, meaning that all the TSI changes, with the generic transition regime will not apply before, let's say, July 2030 to be approximate. Because if the TSIs enter into force in July this year, then they will have 7 years. So we could recommend to this project to switch to the new TSI, because then they will already benefit from the unlimited validity of the time. I think that was the question. Huh?
Thank you very much, Antoine. Now, several questions for you, Juan. How should the term extension of area of use be interpreted? Is it interpreted that BL3R2 can still be used? But where will the subset versions that apply to BL3R2 be defined?
Okay, in this case, extension of area of use is defined in the directive, and is when a vehicle that is already authorized is moved to a new area of use. It means to a new network, and there is a number of technical checks that needs to be verified in order to guarantee the technical compatibility with the new elements. In this case, if a vehicle is already equipped with baseline 3 release 2, and the network where it's extending its operation is already equipped with baseline 3, could be baseline 3 MR1 or baseline 3 release 2, then the vehicles remain technically compatible and it should not be need to do any change. Regarding to where those documents will be published, then this is a 2 steps answer again. This formally, these are the set number 3, the set of specification number 3, which define baseline 3 release 2, and this will be archived in the agency web page for reference, but they will be no longer in the legal framework. They will be still possible to use them for a specific transition period, but then in order to achieve the same functionality, which is currently considered in the baseline 3 release 2, then you have to apply what it has been called the single set of specs principle with the reduced envelope. This means that you have to take the new specifications, the baseline 4 specifications, and then deduct or subtract the new functionalities that defines system version 3.0 and system version 2.2 in order to obtain an equivalent baseline 3 release 2 vehicle, which the only difference is that it includes all the identified error corrections.
Thank you very much, Juan. Another question for you. What is the relationship between version 2.2, 3.0 and BL4R1?
In this case, what is called a baseline 4 release 1 is the new set of specs that will be published in the CCS TSI 2023, which contains inside the definition of 2 new system versions. This is the first time that a new set of specification introduced at the same time 2 new system versions. So in order to produce or to have products that are able to run over 2.2 track sites or over 3.0 lines, you need to use the set of specifications that will be on CCS 2023, which has been called baseline 4 release 1. So baseline 4 release 1 is the set of specifications that contains the definition of both system version 3.0 and 2.2.
Okay, thank you very much. Another question concerning the transitory regime. If a project has already started a design before entry in force, what is the milestone that defines the 3 years limit? Is it the certification of the train? And yeah, please, Juan.
Yes. This has been already covered by Antoine at the beginning, but sometimes it's not simple to master this. The design phase, I will start by the reverse order. The start of the design phase is clearly the signature of the contract with the Novo, and the end of the design phase is the issuing of the EC certificate. So in the question you raise, the milestone that defines that the 3 years limit. Okay, I was reading again the question, but it could be two cases. So if you have already a contract with the Novo, then this means that you will be in the second column. The design phase already started. If the Novo has already issued the certificate, then you are in the third column. That will be you are in the production phase. So that's the milestone that trigger in which phase of the design you are. Of course, it's implicit that between the issuing of the certificate and the start of the productions, the specific vehicle type needs to be authorized, but this is implicit and not explicit into the definitions that are both in all the TSIs, because they are common for defining the different phases.
Okay, thank you very much. I have a very last question for you, Juan, and then a last one for you, Antoine. So Juan, about the harmonized DMI texts, what are the implications in projects after 7 years of harmonization? Is it necessary to modify DMI texts in all ERTMS OB?
Thanks. The new Appendix E contains all the DMI message, and the objective is to have an harmonized translation to all the European languages. So for those countries that share a common language, like French, Italian, German, there will be a unique translation, so it will avoid misunderstanding by different translation into the DMI and to have a consistent message to the driver. In that sense, only new components that are used in new projects will be impacted, and you can check in Appendix B11, which are the defined migration periods for those messages. So the answer is that existing vehicles will remain as it is as long as the DMI is not modified for new projects or for new designs. The harmonized translation has to be implemented in order to ensure operational interoperability.
Thank you very much, Juan. And then the last question for you, Antoine. Will LOC&PAS TSI be mandatory for OTMs? Please, Antoine.
Thank you, Cyril, for this last question. The LOC&PAS TSI will be mandatory for OTMs when the area of use of these OTMs is more than one member state. And it's not mandatory when it's only one member state. I see another question which is a bit in line with that one. It's about the extension of area of use of the OTM when it has been authorized according to national rules. So in that case, we will clarify in the application guide that if the extension of area of use of an OTM authorized in one member state according to national rule is one member state, it will be also possible to apply national rules instead of the TSI in that case. That will be clarified in the application guide of the LOC&PAS TSI.
Thank you very much, Antoine. Dear attendees, dear speakers, all good things must come to an end. We really hope that you enjoyed this webinar and that it fulfilled your expectations. Thanks for attending this event in such large numbers. Thank you very much, Joseph, Antoine, Juan, Oscar, and in the backstage, Jode Bosquera, Olivier Piron, Dorothea Spapen, and Juan Arconco for your work and dedication in preparing for this webinar. Before you go, we would be very happy to receive your feedback on this webinar via the QR code you're seeing on the screen. All your comments are read, and we try to take them into account to improve these webinars as much as we can. We look forward to meeting you again at one of our upcoming events. First, I would like to bring to your attention or to recall that next Monday, on the 19th of June, the agency is organizing a safety leadership training in the agency's headquarters in Valenciennes, in France. This session, which required prior registration, is now complete, so don't show up if you're not registered. Then you are more than welcome to attend our upcoming webinar on the 6th of July about also the TSI Revision Package 2023. As already announced, this next session will be devoted to fixed installations and operation. At the same time, the ETCR seminar will take place in Bruges, Brussels, and Antwerp in Belgium. Then I would like to inform or remind you that registrations to the upcoming European Rail Safety Days that will take place in Tallinn, Estonia in September are open. If you're interested, please visit the agency's website and register. We'll be very happy to meet you there in person. Last but not least, an important communication intended for our applicants. As you may know, the agency is migrating its OSS one-stop shop IT infrastructure to the Microsoft Azure cloud. We have already contacted all the OSS users asking for specific actions to finalize your account in OSS. We would like to ask you to read carefully all the communications sent to you by ERA concerning OSS user migration and to follow the indications provided. If you do not perform any action, your access to OSS will be withdrawn after the migration and you will not be able to access OSS anymore. If you have any issue in performing the actions provided on screen, please contact us via the Contact Us form on our website without any delay. Thank you for your understanding. Having said that, if you would like to stay updated on our activities, please sign into our database by selecting the button Login on our website page. And you can, of course, follow us whenever you want on our social media accounts, Twitter and LinkedIn. Thanks a lot for your attention and your participation today. I wish you a very good afternoon. Bye.